In this short video, I want to go over how to fill out one of these tables regarding a particular type of medical test. So on the individual lab, you will be looking at the strep test. This one is, we'll just say, is generic. Maybe it's a flu test, and we just want to go through the process of how to fill out this table. So the first number you're going to use is the prevalence value. So the prevalence, which is, for this case, 30%, indicates the percent of the population that you're testing that will actually have the disease. So in our case, we're talking about the total number of people who will have strep will be 30%. So this total right here is going to be 30% of the 1,000 people that we test. So we're talking about 300 people. Okay? And so if those 300 have it and there's 1,000 people, that means there are 700 people who do not have it. All right? Now, the next number we need to be concerned with is what's called the sensitivity. So this number tells us of those who have the disease, or in this case the flu, 90% of those will test positive. All right? So of the 300 people who actually have the flu in our testing, this test will, for 90% of those, give us a positive result. So what we want to do is take 90% of 300. So 90% of 300 is going to be 270 people. And then the last number we're going to look at is the specificity. So the specificity of a number tells us of those who do not have the disease, how many of those will test negative. So this says that 95% of those who do not have the disease will test negative. So 95% of the 700 people are going to test negative. So if I do that calculation, I get 665 people will test negative. Now, we can find the other values by making up the difference. So if we go and see that in the have strep column, or in this case we were talking about the flu, we see that there's a difference of 30 people, and over here there is a difference of 700 minus 665, 35 people. And so when we want to figure out how many total test positive for strep, we add straight across. So we would get 200, let's see, 270 plus 35, 305, and then 665 plus 30, which would be 695. And so if you add those two numbers together, we do get our 1,000 that we wanted. So we have all of the numbers that would go inside this table and allows us to finish answering those particular questions. Now for a quick comment, there are two other things you're going to have to calculate. The first one is something called the PPV, which is the positive predictive value of a test, and the other one is the NPV, which is the negative predictive value. And so for the positive predictive value, your book defines this as the true positives divided by all positive tests. So the true positives were those who test positive and have the disease. All right, so that would be 270 people both tested positive and had the disease. Out of all the people who tested positive would be 305. So we're looking at a percentage of 305 divided by, 270 divided by 305. So that's 0.8852 or 88.52%. And then the negative predictive value would be the true negatives divided by all the negative tests. So the true negatives was the 665, and there was a total of 695 total negative tests. So 665 divided by 695 gives us 0.9568 or 95.68%. And just to give you an idea of what these numbers represent, the positive predictive value is kind of saying if you have a negative result, there is an 88.52% chance that that negative result was, if you have a positive result, there's an 88.52% chance that that result was a true positive. And then if you have a negative result, there is a 95.68% chance that that was a true negative result, that you got the negative result and you actually do not have, in this case, the flu. So I hope that video helps. Feel free to email me if you have any questions.